Step 1. The ball rolling down the ramp. This is an example of mechanical advantage. Mechanical advantage is the effort force over the resistance force. The force exerted by a person or object is the effort force. The force exerted by the machine is the resistant force. In this case, the effort force is the gravity, and the resistance is friction. See, as the potential energy of the ball is at the very top of the hill, and the kinetic energy increases as it goes down the ramp, and at the end of the ramp it has the greatest kinetic energy possible. It is also an example of Newton's second law, the mass in the motion. The mass of the ball rolls down the hill and creates greater momentum, which then hits the domino, creating it to fall, and the transfer energy is there.
Step 2. The ball hitting the dominoes. There's potential energy as each domino is standing. Then there's kinetic energy as the ball hits the first domino, and it increases as each domino hits the next one, creating a chain reaction. Step 3. The last domino hitting the mousetrap. The elastic potential energy in the spring that is being pulled apart as the trap is set. When the domino hits the mousetrap cheese, the lever is released and the spring returns to its beginning state. Newton's third law of energy is here. As the lever smashes downward, the mousetrap then flings up from the equal and opposite force applied. Step 4. The balloon rising up. When the mousetrap snaps, the balloon string is under the mousetrap and it is released when the mousetrap jumps. There's potential energy from the helium. There's kinetic energy. As it rises up, it gains until it hits the inclined plane, causing it to slow down and stop until it eventually will rise again.
Step 5. The ball rolling down the ramp after the incline is produced by the balloon's force. The potential energy is at the very edge of the incline, and the kinetic energy increases until the cup is hit at the very end of the ramp. Newton's first law is demonstrated in this step because the ball wouldn't move until the incline would be raised, forcing the ball down the slope. This is also an example of the mechanical advantage. It is the same as the exact thing as in step 1. Step 6. The ball hitting the cup. Step 7. The cup hits the ball. And step 8. The ball hitting the cylinder. These are all examples of basically the same exact thing. The potential energy is just the object staying where it is, and then as the one hits the other, the kinetic energy increases and then decreases as soon as it hits the next object.
Step 9. The cylinder hitting the balance. The cylinder sitting on the edge of the table has great potential energy. When the ball then hits the cylinder, it falls off, creating a greater kinetic energy to transfer to the balance. Step 10. The cups swing and hit the giant lever. The balance is set up just right so that the kinetic energy transferred from the cylinder will cause the balance to swing. It'll swing perfectly with enough force because the back end is weighed heavier than the front, so it'll give it that extra push to knock down the giant weight lever. There's also mechanical advantage here. The effort force is the ball hitting the lever, and the resistant force is the normal force.
Step 11. The lever hitting down on the toothpaste, squirting it out. The toothpaste has potential energy to get squeezed out, and the force of the lever dropping down, squeezing out the paste towards the end of the tube, forcing it out. As it stops, the kinetic energy is now reached its max, and the tube will no longer squeeze out the paste. This is an example of the mechanical advantage. The effort force is the lever's impact, and the resistance force is basically Newton's third law all over again, the equal and opposite force. As the lever hits down, it will bounce back up, and then the